Okay. Here we have seen sometime question asked outside of the syllabus, but indirectly such questions are related with syllabus. Like you can talk about the expansion path. 2017 one question is asked from expansion path. So it is known to us this expansion path topic is not related with directly the syllabus, but advanced micro, uh, from advanced micro, this question we can take where there is talk about the expansion path. So what is actually expansion path? What is expansion path? So first try to understand the term expansion path is known to us well. It is the locus of points of tangency between isocost, isoquant and isocost line, like this. Say different isoquant, a sum of some combination of output can be produced, say Q1, isocost line, say one isocost line we can draw, say AB. Again another isoquant Q2, another is isoquant Q3. So when we touch, we will get a path which is called expansion path. So expansion path is what? It is the locus of the points between tangency between isoquant and isocost. So one question is asked here. What is our question? Derive the expansion path for a firm operating with Cobb-Douglas production function. The firm who is operating with Cobb-Douglas production function. So what is the Cobb-Douglas production function? Say Cobb-Douglas production function is that this one Cobb-Douglas production function, Cobb-Douglas production function, this one Cobb-Douglas production function, say x is equal b naught L to the power B1 K power B2. This is the Cobb-Douglas production function, which is basically taken research or applied economics. So in research field and applied economics, such type of production functions are taken basically. Now for this production function, we need to derive the expansion path. So at optimal factor combination, at optimal factor combination, at optimal factor combinations, what are the conditions are to be fulfilled? So Cobb-Douglas at optimal factor function, the following condition, the following, we can write the following conditions are to be satisfied. What are the conditions? Number one, marginal rate of technical substitution of labor for capital. Technical substitution, labor for capital, it must be equal with the wages divided by rate of interest R. This is number one equation. This is the rate R, price of capital, W, it's the price of wages, price of labors. Second condition, marginal rate of technical substitutions. Marginal rate of technical substitution lever for capital, it would equal marginal product of lever divided by marginal product of capital. This is the second condition. So from this production function, now we proceed to find out the marginal product of labor as well as marginal product of capital. So what will be the marginal product of labor? First, find out the marginal product of labor. It will be the differentiations of x in respect of labor. So when we differentiate the production function, that is x with respect of labor, then we will get marginal product of labor. So when differentiate, B1 comes here, B1, B naught, L, B1 minus 1 and K to the power B2. So here B1 and this one B naught L B to the power 1 and K B to the power 2, and this L to the power minus 1, we can write this one 1 by L. So ultimately this much B1, this will be, the value of this much is x divided by L, or we can write this one B1 average product of labor, but we use this expression only, B1 x by L. So this is the marginal product of labor that we got, B1 x by L, after differentiating the production function in respect of L. Now similarly we can find out the marginal productivity of capital also, marginal productivity of capital also, that also differentiate of the production function in respect of capital. Similarly here we will get B2 x by capital, x by capital. So we can write this one B2 average product of capital, but we will use these portions. Now we are in the position to find out the marginal rate of technical substitution of labor for capital. Therefore, marginal rate of technical substitution labor for capital, just we will put the value of marginal labor and marginal capital, that is B1 x by L divided by B2 x by K, that is capital. After simplifying, x will be cancelled out, so B1 by B2, this x will be cancelled out, and capital by labor. This one, this is marginal rate of technical substitution. Now substituting this value in equation 1, substituting the value substituting K by L, or substituting K by L for marginal rate of technical substitution labor for capital in equation 1, then what we will get? In equation 1, we just put the value of marginal rate of technical substitution of labor for capital x by L, that is B1 by B2 into K by L. K by L, this is the value of marginal rate of technical substitution, already we have calculated, net wages by rate of interest. So when we do simplify these expressions, we will get like this, K is equal K is equal B2 reverse B1 into again W by R into lever. So this is the production function. So this equation 3, we can write equation 3 shows the production expansion path of Cobb-Douglas production function of Cobb-Douglas production function. This is the conclusion of our answer. Actually, this production function is most popular in applied research. The Cobb-Douglas production function is most popular. We will discuss a little more about this Cobb-Douglas production functions. What is actually production function? Cobb-Douglas production function is very popular in applied research. How this is popular? Why? Because mathematical calculation and mathematical simplification become very simple in this production function. Suppose this is our production function B naught, say L to the power B naught L to the power B1 K to the power B2. From this production function, we can find out the marginal productivity of lever and capital very simply. So, number one, if we need to find out the marginal productivity of lever and capital. Now, see, A, marginal productivity of lever. Simply we differentiate the production function in respect of lever, that is del x by del L. So when we simplify, B1 comes B1, B naught L, B1 minus 1 and K to the power B2. So when we do simplify it, B1, so B naught L to the power B1 K to the power B2, and this L to the power minus 1, you can write it like this, 1 by L. So this portion B1, that was x by L. We can write B1 x by L means average productivity of lever. So marginal productivity of lever is what? This constant B1 multiplied by average productivity of lever. Similarly, marginal productivity of capital we can find out B2 average productivity of capital. Same process we can find out the marginal productivity of capital, that is the constant B2 is multiplied by average productivity of capital. Next, marginal rate of we can find out the marginal rate of substitution also. Marginal rate of substitution also we can find out. Marginal rate of substitution. Marginal rate of substitutions. How we can find out the marginal rate of substitution? Marginal rate of substitutions. So marginal rate of substitution lever for capital, already del x by del L, similarly del x by del K, that is marginal product of lever divided by marginal product of capital. So already we have got this figure. So we can write B1 x by L, B2 x by K. So ultimately here B1 by B2, x cancelled out, x cancelled out, so capital by lever. This much will be the marginal rate of technical substitutions of lever for capital. Again, we can find out also from this same production function, mostly the question is asked the elasticity of substitution. Elasticity of substitutions. Elasticity of substitutions of Cobb-Douglas production function. So which is given sigma is equal differentiate K by L, again divided by K by L, this one divided by differentiate marginal rate of substitutions lever for capital divided by marginal rate of substitution, this one. After putting all the values, that is D K by L, after putting the value here, marginal rate of the value of marginal, already we have find out the value of marginal rate of substitution, that was B1 by B2 into K by L. This is the marginal rate of substitution, similarly divided by B1 by B2 into K by L. This is the value of marginal rate of substitutions. Here we can write D K by L when you differentiate it, K by L, and this one divided by B1 by B2, and D B1 by B2 into K by L divided B1 by B2 into K by L. Now by simplifying, we will get here only. So in case of elasticity substitution for Cobb-Douglas production function, result 1. This is the result 1. We can find out more results, many more results from this Cobb-Douglas production function, like factor intensity. We can discuss factor intensity. We can talk about the factor intensity of Cobb-Douglas production function. So factor intensity means in Cobb-Douglas production function, factor intensity is indicated by B1 by B2. This is the factor intensity. That is, in Cobb-Douglas production function, in Cobb-Douglas production function, in Cobb-Douglas production function, factor intensity is measured by by what is the ratio? By the ratio of B1 by B2. This is the ratio. The higher this ratio, that is B1, B2, higher this ratio, the more lever intensity. In the production function, more lever intensity or more lever intensity technique in the production function. Similarly, efficiency of production can be measured. Efficiency of production That is the efficiency of factors productions, the efficiency in the organization, also measured of the factors of production, efficiency in the organization of the factors of production is measured by the coefficient, what is the coefficient here? B naught. Coefficient B naught. More the efficient firm will have higher value of B naught. The more efficient firm have more the value of B naught. In compare with the less efficient organization. Similarly, we can show the return to scale. We can also show the return to scale. What is the return to scale? The return to scale, we can show also the return to scale. If A plus B is equal 1, then it will be constant return to scale in production function. Constant return to scale. If A plus B less than 1, then it is decreasing return. To inputs. Decreasing return to inputs or in our production function. If A plus B is greater than 1, then it is increasing return to scale. That is why we can say that Cobb-Douglas production function is most popular in applied research. Okay, thank you.